Hello everyone. So we are going to see. We have seen a lot of overview of NoSQL, right? So we are going to see CouchDB. Maybe we can consider this a basic to intermediate level of session. Um, so first, I want to explain what are the philosophies that what built on top of CouchDB is built on top of that. So first, it is a document-based DB database, meaning here the document is like in the format of JSON, and it is exposing the API in the form of REST using the HTTP methods. So, for concurrency purpose, it uses MVCC, which is multi-version concurrency control. So I will explain that in detail. And then CouchDB can be distributed and still it can be highly available. So these are all some philosophies that taken care in CouchDB. So usually when it comes to database, we usually create a database first, and then we do some CRUD operations on it, like create, read, update, delete. So and let's see, like I have some demo to show that how can we create a DB and to update and all those CRUD operations. So first, in SQL, I mean SQL, we create a database using the command like create a database and we give database name, right? So here, since CouchDB exposes everything in the REST or HTTP, it follows the convention of the REST, and so I am using a REST client I am familiar with, which is Insomnia, but we can very well use C or curl and Postman, anything, any sort of that kind. So we need to notice, like here I am using the HTTP method put, and admin is my username password, so I am using the format for basic authentication. So I am giving in the URL, and the address is where my couch is running in my local machine, and then the DB name, which is bookstore. I am so in this session I am trying to build a small website which can list books with various fields like title, price, sort of. So I named the database name as a bookstore, and I am trying to create it. So since I am already having that database, I am getting some meaningful error. Usually in like SQL kind of DBs, maybe in Oracle or other stuff, we usually get some error code, right? So whereas here we are getting some meaningful error, which is like file exists and database could not be created. So I am deleting the resource. Like in this case, database is the resource. I use the delete method and I'm deleting that. So we see the responses here. 200, which is HTTP status, and the response is OK true, meaning the request is successfully processed. Now we are again trying to create the database. Yes, we have created it. So we got the success response. Then we are moving into the other basic operations of document. Since it is a document based, so everything here the document will be in the JSON format. We can post the data, we can update, delete, and whatever in the JSON format itself. So let's create some books. So I am creating a book, so with attributes like title, author, price, rating, and type is a book. Okay. So here in the URL I am mentioning the DB name, to which DB I need to write this data document, and for that purpose I am using post, which is usually in REST convention, post will create new resources and put will be updating the resources. So if you see the database, create database, nothing changes, like the URL remains same and only the method changes, right? I leave it to you to explore why they didn't use post for this, and I give some key like it is idempotency related thing. So put usually idempotent, so maybe you can explore more on that. So the same URL, and we are using post HTTP method and trying to create the document. Yes, it is successfully processed, and then we are getting some response with OK, true, and ID, and we see some strange attributes which is meaning revisions. So a document is created successfully. We will come to that revision later. What is revision meant for and why we maintain a revision of a document. Okay, so now we need to ensure whether the data is written into the DB correctly. So we are trying to do some read on that. I am copied that ID of the document. I am using get request for getting a resource. Yes. So if you see, we are getting all the whatever attributes that we define, and the couch defines two attributes like ID and rep. So now I see like price of the book has been increased or decreased. So I just wanted to update the price. So I am trying to update that document. So I use put, and the URL will be, this is the base URL. I have selected the base URL, and then the DB name, which is a database name bookstore, and then the ID of the document. I will replace with the new document that we have just created. So I have replaced it. Yes? You are asking, are you asking whether we need to give all of the attributes or only the price? Okay, there are two different things. Good that this question comes earlier. Like, so I am using the basic update, which is like every time I am going to update the whole document. So, but there are options to update a particular field in a document. We need to do some handlers in the back CouchDB. Maybe we'll come to that later. I haven't added any demo for that. I will tell what theory behind that. So now I have changed the price alone, but still we need to have all other attributes intact, and I am updating this as a whole document. And when I try to do that, so I am getting conflict, document update conflict. So what does it mean is, like, so whenever we are trying to update a resource, so it creates another revision of the same document. So it will retain the old revision, and it will create a new revision of the updated version. So since to update any document, we need to give the latest revision of the document. I will tell why we need to keep the revision always whenever we need to update a document. So till then, yeah, it is just like a convention. We need to hold on that. So I am getting that latest revision of the document, and I am giving that as a query param. If you see the original URL preview, I am giving that as a ref equal to whatever ID is there. Let me try to find the latest revision of that document. In HTTP, there is a method called head, which usually, if you are asking any resource, it will give the specific information of the resource. So here in this case, CouchDB designed the resource, that specific information to be that revision ID. Let me get that. So I am giving the document ID, and it returns the header only. So it is a lightweight API. So to get the latest revision, we no need to do the full. No need to get the full document, right? So we can just know that revision of that. So we can use that head API, and I am getting the latest revision, and I am giving that here. Yes, it's updated. So if I read now, it should be 730. Yes, 730 rupees. So it has been updated. And similarly, we can delete the document. So if you look into the revision, once we have updated the document, it has created another revision. So the revision IDs keeps on changing. So to delete the same particular document, we need to again get the latest revision. Since we already know, I am taking that, and because delete is again another one kind of update. So I am trying to delete the document. Okay, I need to change the ID. I need to give the latest one. Yes. So we have deleted the document. Yes. So if you see the response, there is another revision. So it is not really deleting the data or document. It actually creates another version and marking that as a deleted true. So hereafter we won't get that data. That and all CouchDB internally maintains, like if it is deleted, we shouldn't expose into that API. So these are all some internals that CouchDB maintains. So this kind of state is called tombstone data. So where why do we need to store? If it is deleted, we can delete all the revisions and we can go, right? Why do we need to have store still the deleted revisions? Means in the distributed systems, when there is a lot of replication of data, if there is data is deleted in one particular node, and it should be reflected in another node. So for that, either we need to keep off the deleted records in somewhere else, or we can mark it as deleted. When we update the same replicate the same data, there also it will be marked as deleted true. So these kind of replications will be maintained by these revisions. So this is one of the use case why we need revision. Then one more thing, I will create the data again since we have deleted that. Yes. First use case. Yes, yeah. This replication thing. Okay, so you are deleting a data. So think CouchDB is like. Maybe I will come to it later when I am talking about distributed system. I will explain that too. Yes. No, we couldn't. When we try to use that same ID and try to do some update or delete, CouchDB treats us that since that is deleted true, it will be not found missing. No, it will be always there. Yeah. There's a lot of questions. You mean whether 10 revisions will be maintained? No, all of the revisions will be maintained. When to clear that and all is in our hand. There is an option for compaction and cleanup. Yes, only the latest version will be retained and all other versions will be deleted. So that and all will be in the maintenance stuff.
So how does it store the versions? Let's say it has 4 versions.
Yes.
So if I want, I can access the version number 2.
Yes.
So how is it stored? Is it like only the prefix stored and you comment everything in the last 4 versions?
No, the complete document will be duplicated. Yes. That's what. To access the old revisions, I will create the document again. So I have created. I will update this something like so that new revisions will be created. For that purpose, I am updating it. Oh, sorry. Okay. So to get all the versions of the particular document, so I am getting using the same REST API like get document, and I am passing a query parameter like revs info true, which means it will return the document, and along with that, what are all the other revisions are there. So So to access a particular revision, the same API, and I can use, I can pass maybe to access the previous revision. I am copying that revision ID. So if I am just asking for that particular revision, and we can retrieve that as well. So usually we shouldn't rely on the previous revisions, because that doesn't mean what those revisions are not meant for some operations or something. It is for the concurrency purpose that I am going to explain now. And one more API I want to explain about this, like to fetch all of the data inside a DB. So we can use that all docs API. So the same get method, and inside bookstore database, and for all to retrieve all docs we are using all docs API. So in this, to notice, like we have couple of parameters called include docs and skip and limit. So if I am just giving all docs, it will only give only IDs of the documents. Maybe let's create another book so that we will get at least 2. Okay, I have created 4 documents. Now if you read, you see 4 keys, IDs, and the latest revisions of each document, and all will be listed. So if I want to have that document, original document, then I need to pass a query param called include_docs to set to true, so that I will be it will give all the document itself, like with the key document, and we will be getting the document. And the skip and limit is used for the pagination purpose. So let me limit the data with one number. So at any particular time we will get only one data. For getting the second page, just imagine a page with one data. To get the second page, we need to use skip, and I am skipping one data. So I am getting the second document. So if you notice, the offset is set to 1. So the first document is skipped, we are showing the second document, and since the limit is also 1, we are getting only one document. So this is used for pagination purpose. And to see the latest changes, whatever we have done, so we have db_changes. So if you have seen, like we have deleted a document, and we have created new documents. So those are all some audit purpose. So these are all some basic APIs that we can operate on document, couch document collection. Yeah, there's no. So everything here is a separate document. There is no relation between document, and there is no, in MongoDB all are grouped into a collection, right? So books means books, there will be a collection, and books.all. So nothing. If you want to retrieve all the book, then the type is the only thing. If you are, yeah, everything is different document, separate document. There is nothing related. No relation between 2 documents. In an application, bunch of okay, in those use cases, what we need to do is, like user is a document and book is a document. We need to have our own attribute like user ID, and we need to manually map in the application server. Not DB is not really enforcing that referential integrity. We need to make it move that into the application logic. Mm. Yeah, maybe just let's hold on that, like key value pair. Couch also uses some key value strategy to query the data. I will come to that too.
But like just curious, like why users are stored as documents and not as, I mean, usually typically like users are well defined and they have structure. So usually I find users like that, like defined in a relational database, like not in a document. I'm just curious. Well, this is an example that you just gave. No, I was wondering, I thought like you work on an application where user and book as a document and then like user like reads a lot of books, something like that. No, nothing wrong. Okay.
So I think he's talking about in Mongo there's a concept called collection. So I think he's saying that all users
for our application, we will have only one single database which will have all the documents belongs to our application. Okay, when we come to this station, we need to have more than 5 databases. If it comes to more than 5, if we have 5 databases, then we need to find all the databases. We need to those databases in our application. That thing I am facing, I think.
So you are asking like that's what this is the querying part, right? How to query the data for a particular user, kind of
Storing also.
storing also.
We have user sign up.
Hmm.
It's like we have user sign up. All the data we storing some user take or something. But in those we take user database.
Okay. Yeah, well, I would recommend like anything like users not to be a document because it's well structured. Each user is well structured. Right? Like I mean, there's not going to be me and you are not going to be totally different and all. So like whenever it comes to users and relations and stuff, like it's recommended to use relational database. But if you want like unstructured things like books or something like I don't know, like that's when you use document.
Yes. Yes, we can do that. Here we can give some IDs like. Which one? No, it for updating the document, updating like update and delete. Yeah, revision is mandatory because we need to know. We need to be sure we are updating the latest version. By the default? No, because when in Couch, see, since we are reading the data, so just imagine this scenario like. I will answer this in this. So I will show how to create that ID because it gave some error. So okay, so now we have seen like basic operations like read, create, read, correct. So that gives some revision, which is a change field. So revision is already used for that replication purpose that I have already explained. Now mainly it is used for the concurrency purpose. In SQL, see the same thing, same use case. If we are doing in SQL, usually we go with books table and we create some columns, right? So just imagine there is only one book has been created. And if person A tries to read this particular row and person B tries to update that, write something on that data, maybe update the price to 730. So if you just imagine they both are doing a concurrent request. So at that time, we should make sure that data is consistent and it is not corrupted by write and read operations. So in SQL, relational database, what they are doing is like they acquire a lock, either it is a read lock or write lock, pessimistic, optimistic kind of. So based on scenarios, they decide the lock. So for the basic use case, we take that as a write lock. and till the transaction completes to the read person, the person here who wants to read the document needs to wait till the transaction completes. So this is where relational DB gives some more priority to the consistency rather than availability. So whereas in Couch, so when we are creating the same scenario, we are having one book document. So as we have created like earlier, right? So we have one book document, and person A comes to read that document, and person B simultaneously tries to write a document. And what Couch does is it gives the latest information, whatever is there now. So it will return that as a response for the person A. For person B, it will check the rev query param, and if it matches with the latest revision that presents here, and it creates another version like this. So the person A is not seeing the latest version, but still he receives some data, but eventually the database is taken to a consistent level. So now the update is there, so the read and write operation has been isolated, so the DB is always available to the user, even for write and for the read. So to make a write, we need to make sure I am having the latest revision, so that I am having the latest copy of the data that I am going to modify. So that is where we are using that revision. This is the main purpose of that revision. So this type of concurrency is called that MVCC, multi-version concurrency control. So in this type, Couch gives some more priority to the availability than making sure the data is consistent across the readers. So no, because only one revision. For example, if person A reads it and person B tries to write it, he gives the correct latest revision, and it creates a new version, and then it creates a new version. Another record should be processed with this new version, not with the old version. So document update conflict will be there. He will get the error. I mean, whatever we got right, update conflict. So he needs to again use a head request to get the latest revision, and or if he is interested what data is actually changed, he needs to get whole document, then do some operation, then again go with that.
Should we always do the head and then
Yes. If maybe we can optimize that, we can try updating it. Mostly it should be updated. If there is an update conflict, maybe we can then do a head and do that. Little more efficient. That's all. Couch, yes. Yes. So the next part is like querying. Usually, once we have so much of data, then we will try to query like count of the books and what is the max price of that book, and whether it is a list of audio books or list of textbooks. Those are all some different queries that we will be performing on the data. So usually in SQL, I mean relational DB, to query the data, we use select and use lot of conditions in where, like, group, by, everything. So in Couch, we write design document. Is a special it's yet another document, but it has some special meaning to Couch. Maybe I have some demo for that too. Yes. So this is yet another again JSON document. Here the ID alone we need to give like underscore design and a design name. So this is a convention of Couch. We should always create a design document with ID underscore design slash some design name. Here in this case I name it as books, and inside a design I can have a lot of views. Like to query all the textbooks, I need to create a new view. To query all the audiobooks, I need to create another view. So, and then there are other other fields like shows, which is like another kind of view. Since Couch deals with HTTP, we can render the HTML response to the directly to the client. So it gives some basic level of what. Since it exposes REST, we can actually make use of that and take advantage of rendering it as in HTML itself, so that we don't need to create a separate front end for. So if it is simple enough and we are okay with that, maybe we can use this feature. Otherwise, yeah, we need to, as usual, go with the front end, so consuming this JSON.
Client has to build the push the data.
Now, CouchDB itself not push the data. CouchDB itself will give the response as HTML, not as the JSON.
No, what I'm asking is in case of update as you go along, the person is writing or reading, you will not be saying in case of comments, like in every user, it will not be the latest comment that you are reading. So
No.
the latest will be pushed to the user who is already reading. It's not like it's like IRC.
I'm not sure, but whatever I have know, like we need to get that. It won't push. But I don't know whether it has some configuration for push. Yes. So there are. Sorry.
Actually, there's a DB called rethink that allows the DB itself allows
Rethink DB. Even Meteor does that. Meteor framework does that. That push. I'm just waiting for this. So inside views, we have a lot of views. One is for getting all the textbooks, and every view should have a mandate field called map and optional field called reduce. So this was Ram actually explaining, right? So MapReduce. And then for audiobook queries, I'm only using the map function. So the value of a map is nothing but a JavaScript function. Couch uses JavaScript. It actually runs a parallel JavaScript query server at the backend, and whenever we are creating a design document, it takes the map function, it processes all the documents with this map function and create an index out of that. That is a key value pair. So whenever we are querying for this particular view, then it goes and directly to that index. It won't touch the document. It goes directly to that index and it will return that index. So it will be performant. To that purpose, they are creating a separate index for each and views. So and one more thing I need to Couch itself provides a web client. So now we are using some REST client, right? Instead of that, Couch itself provide a simple web client called Photon client, and you can see the database that we have created. Inside that we have 4 documents. So each document is like, so internally Couch stores that as a key values. So every document will be a value for it, and it stores that ID as the key. So that is internal to CouchDB. So when we are viewing that, if you see here all documents, this API uses that underscore all docs. So internally it uses that and gives all of the documents. So here itself we can update like an individual field. We can save the documents, and the revision has been changed. So in this way we can use take advantage of this web client itself. We can create DB and document anything. So let me create that design document. I'm refreshing that. So if you are, so we have one more design document, and in the views, if we see, we have 2 more views, audio books and textbooks. So what happened is, now when we create a design document, all of those 4 documents are there, right? Here, everything will be sent to this map function, and it will create a key value pair like this. This is the map function for the textbook thing. So all of the document will be processed by this function, and it will check whether this document type is book. If yes, then emitting the title and as a key. I don't need any value as of now. Then I am spitting out as null. So key will be there, and there is no value for that. These kind of indexes will be created. So on going to that view, we have 2 books now. One is clean code and refactoring. Both are a type of, both are type of book. And if you are going to open that audio book, only that audio book is available, right? So the function is nothing, simple if condition. If you see here, you can see that I am just checking whether it is an audio. So it will map only those audio files as key, the title of that book as key and null as value. If you want title and some other like price means, we can emit that as a value here. So it will, here we will be having key and the value will be the price, or the document itself can be the value, or anything with whatever we can do with the document, and we can express that as a value. And key also, if we want the title to be the key, we can keep the doctor title, otherwise the price can be the key, anything, whatever attributes that is available in the document, that we can use as the key. The main feature is like couch sorts all the indexes based on the key. So if you see textbooks, the clean code, and it is in the alphabetical order. So they have some collation rules, which mean you by that they are ordering that. For example, first the number gets the priority, then the special characters, and then the alphabets. So kind of rules they have. So based on that, they will be sorting the key. So we can leverage that for sorting purpose as well. And but we have the limitation. For example, in the relational DB, if you want to sort based on multiple columns, what is that class for that? For sorting, select, and then I couldn't remember. Order by, we will be giving some column, right? Ascending and descending. So we can mention multiple columns there. So first column will be sorted, and then within that. So kind of process is difficult in Couch, because the implementation is like we have a single key, and if we need to add based on title, and we need to sort based on price, means we need to add an array of keys, and it has its own complication, like it doesn't sort by the natural rules that we have. It has some collation rules that CouchDB has, and so those are all some limitations or complications that comes with sorting documents in the CouchDB. So while choosing CouchDB, we need to think whether we are going to sort with multiple columns, or we are going to filter with multiple columns or attributes. Then we need to think of whether we need really Couch kind of thing. That is one thing. So since the view is indexed, it will be very performant. So we can just get by the key. So for example, if I want to, if I am indexing using a price, for if a book is like less than 700 beans, I can pass it in the key attribute in the here. I can pass it as key, something like start key. Maybe I want to get the books within 600, and the end key should be 900. Then it will fetch all those documents lies within the key level. See here. Yeah, if I have created an index with the price, then the key would be price like 725 something. So I can give the start index, start range and the end range. So it will fetch only those documents. So for creating for fetching multiple queries, we need to create multiple views based on our requirement. And since it is creating new indexes for every view, and every query will be very performant. So whereas in I'm just comparing relational database with this. There also we have indexes. It also has some. It will actually duplicate the whole table or database into a separate thing. Whereas here only the key will be duplicated. And whenever we are updating a document, and the index also will be updated. For example, if the price is changed for a document, and the index also will be updated based on that. But whereas in the relational DB, if you are changing a price, then the whole row or the duplication wherever it's there. For example, if you are creating index using a price and the column and the title, then all those are duplicates of this original table. So we need to create or update those are duplicates as well. So there is an overhead there. So we can avoid that in CouchDB. Yes. If you see the view, you can see the key and it internally maps into an ID. Like this. So it is visible. So and internally Couch uses B tree, sorted B tree as the data structure. So all of the keys will be sorted per index. So every index is a B tree data structure. So everything will be sorted. So insertion will be in that O n log n kind of time complexity. And as I told earlier, Couch uses internally a JavaScript query server to perform these kind of view creation, index updates whenever there is a change in design document or creation of design document. Yeah. So other stuff like so since we are creating multiple versions of the same document, over the period of time, the size of the DB will be huge. So to maintain that, we can do the compaction on every DB. So these are all some admin operations that we can have. So inside the bookstore, which is a database, and we have options for compact and cleanup, and there are 3 types of compactions. Whether I need to do the compaction on all the documents that we are having in the database or only the view files. So whenever we are updating a view file, at that time we are creating some changes in the index, right? So it creates another index. It doesn't affect the old index. So it creates another index. So for example, we have 100 books and I am updating a price of that book or name of that book and key is name, then it will create another index. So the old view index also will be there and the new index also will be there and the latest one will be point to that query, that view function. So if you want to clean up the memory, then we need to do the compact views, clean up views. And the other option we have the whole document itself. We can remove all of the old revisions of each and every document. We will only have the head latest version. So these are all some maintenance options that Couch provides us.
These are something like this.
Yes, we can use for that.
We use for technical kind of map used to index. Like, whenever you create a view, there will be an index. So it is used for filter. You are right. Compare to a view.
Can we compare? Can we get whole result of the filter result from our views?
You mean can you give the result of execution of one view into another view. Is that what you are asking?
Yeah.
No, that is something which
But I think we can do that by using Reduce. Let's say you are doing the math. By using Reduce, you can do what you want.
I don't understand your question.
So what he is asking is, so one view gives a result, does a filtering and gives a result. He is asking if that result can be taken by another view and then further filter. Can we do that?
No, we cannot do that.
So since reduce is getting mentioned, do we want to actually?
Yeah, I forgot to actually do that. I will do that now. And first I understood your question differently, like whether we can retrieve both textbook and audiobooks. For that only I have just rewrite that map function. So if we have this condition, maybe we can have both book and audiobooks. But your question was different. So.
Hey guys, quick time check. We are going to be at the schedule time.
Maybe
So we'll
give
have
some 5 to 10 minutes.
And after this, I can have one more.
Sir, we can't do that hard way imaginary research.
Uh,
That is why I'm asking that question. Now you do that, you said you make array of views, but it's not like that. Have two views, have one another dark view. First two view doing something based on the unique key. They're like audiobook or other view. Then the dark view function will take the result of reduce the result of about two view functions and do some
so
filtering on the key data. Yeah, can we do that?
no, that is not possible in Couch because every index is a separate outcome of a isolated map view, map and reduce functions. So we won't have context of the another map functions output or another indexes reference to access in this map function. So map function, whenever we create a new design document, a map function is what newly or freshly processed. So we cannot get the other context of map or the outcome of that map, which means index. So every map is isolated.
So Raj, have you covered reduce?
I forgot to. I missed that. Good that. Yeah. So for textbooks alone, I have mentioned a reduce, and underscore count is a function of built-in function in CouchDB itself. We can write any other JavaScript function, valid JavaScript function, like map. We have written a function, right? Kind of function. Since usually count some max, min, and all. Usually we there are commonly used reducers, right? So Couch itself gives these kind of built-in reducers. I am making use of that on count, and to get that, so in query params, if reduce is true, yeah, we can get the value as three textbooks are there. If it is false, sorry, so we are getting only the keys. And if you want to get the docs as well, then include docs equal to 2. So then the docs also will be there. Yes. 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 So for example, if I want to update any image for that particular book, then it stores document as the exact document. There is no binary conversion base 64, nothing. It stores as a document, and still we can access over the HTTP protocol itself. So it is truly a document. Thanks for the question.
So Raj, since we are on the review, I just want to answer the other question which you had earlier also, where you wanted to operate across libraries and then do some operations. I want to know how many libraries has this book and stuff. In those cases, if we are operating at that level, we will be having books and we will be having the library as an attribute to the book, right? And then like we'll be using reduce to do the aggregations. Like for example, I want to know for this particular book, like how many of this book is available in this library. For that, we'll be writing a reduce function because reduce actually summarizes information. Just wanted to link this to that.
Correct. So for example, yeah.
All the books in all library have to be reside in one database. For your answer.
No.
Yeah. So the thing is, it depends on where we are operating. If you want to like initially I mentioned an example where each I took the example of books being being inside libraries, right? So if you are building a system for each libraries, right, then we won't be looking at libraries from a higher perspective. Each library will be worrying about the books they have. Then each library will be a database. But if we are looking at books and libraries from a higher perspective, we are building a system where we want to aggregate information about books being available in various libraries. Then we won't be doing that. Then we'll be database is just a high level. It's just for multi-tenancy. It's not for classification. So since this doesn't have any classification, like Mongo you have collection, there is nothing for CouchDB. So all you do is it's very pure. It's MapReduce. That's it. So what you will have to do is you will have to have it as a document attribute, and then you will have to reduce it to arrive at whatever you want.
But I see this database is something similar to validation which Mongo has, because it's all in one server.
Actually, even Mongo has databases. So databases has multiple collections. So that's so. So database, I mean, it's ideally supposed to be used for multi-tenancy.
So yeah, so other maintenance purpose like link to document, we can have other documents ID in this. Couch supports one level of hierarchy, like one level in depth it can fetch the other linked document. For example, if books have user ID, if I am passing a parameter get the documents included, then it can get that user ID document too. But otherwise, if user has some other thing, it won't fetch. So one level down, it can fetch the linked ID. But still, the document is not related at all. Couch gives some support for that. That's all. And distribution and replication, we can install Couch in many nodes, and we can reverse proxy through Nginx, so that based on the ID of the document, it can decide which bucket it's to go, like whether node 1 or node 2, node 3. So those kind of distribution can be done. And since distribution comes into picture, we need to take care of the data loss. So replication also comes into picture. So we need to ensure that whether 2 to 3 replica of data should be there. So for that purpose, if you see here, we have replicator. So we can give the local database from here to another node. We can transfer the data, or from other node to here. So both way. That's what Ram mentioned. It's a peer-to-peer replication. So any node can transfer his own database to other. If authentication is all done and there is no authentication problem, then it can transfer the database into another node. So to maintain that replication, since in distributed system, data loss is something we need to take care of that. So replication is the only way, and Couch supports that. So Apache actually open sourced CouchDB, and then many other communities and companies have been created their own variations like PouchDB. PouchDB is like we can use it it's a lightweight version of CouchDB, and we can use it in the browser. Most probably the use case will be like offline storage. Whenever there is no internet, for example, just I am taking a hypothetical example like Facebook. If Facebook uses PouchDB, whenever you do command, even there is no internet, it can store into the PouchDB. When the internet comes from PouchDB to their central server, it will update. For those kind of purpose, PouchDB is introduced. Developed, and then Big Couch, the Couch DB itself served as a cloud-based service. So instead of installing our own CouchDB in somewhere, we can afford some amount DB in the cloud itself. So they are, they have also open sourced that. So that is one thing. And I just want to mention where CouchDB falls in the cap theorem. So yes, since CouchDB can be highly available, and since because it uses indexes and it uses that MVCC, so it doesn't block any user for write and read. So it is highly available system, and also it can be distributed across locations. So it lies within that intersection of partition tolerance and availability. Whereas this consistency is a trade-off. It will be an eventual consistent database. So that is what Ram mentioned. Relational usually gives priority to the consistent, immediate consistent, but whereas this kind of NoSQL, most of the NoSQL gives the eventual consistent property using the multi-version thing. Yes, that's all I have. Thanks. Thank you.